Just want to do a quick scenario with this yet another carrier Weathermaker. This just came in for a replacement due to a bad circuit board and overall condemned due to age. You can see in the original picture the coil actually faces the other way, and it was in a plenum, which we call an uncased coil, which makes access pretty difficult. Typically, we take the door off, try to get into the A coil, and try to inspect the heat exchanger that way, or remove the blower. You can see the coil is smaller than the width of the furnace, obstructing airflow. Even with inspections, you can't get a full inspection on the right and left cell. Let's take it apart. Removed all the screws already, make life easier. Screws at the top, screws on the inducer or at the exhaust port, and all screws in the front. We already removed the blower. It should come right out. So I'm preparing for a training class for our crew, and I was running through some experiments, if you will, some theories about heat exchangers. So this is a heat exchanger from a Weathermaker, a popular brand that we probably installed and serviced over the years. What I'm going to do is simulate heat in a heat exchanger. So the first thing is this heat exchanger had 3 cracks, hairline cracks around it, and the argument is they're just hairline cracks. So the scenario is I want to demonstrate I put heat into a cell. I'll use a torch here and see if the crack does indeed expand, and it does. I have a couple tools that I'm going to use here: thermal imaging camera and a little smoke wind indicator that puffs out some smoke. And so my first theory is, when you apply heat, the crack should expand. Second theory is, being that it is a heat exchanger is a negative pressure, so the inducer is pulling exhaust through the heat cell, right? That I would think if I put a little smoke to it, it should suck in. And I want to see what happens. Now, I obviously removed the blower, so we just have the cell here, and the torch is going right now. So I'm just waiting for this thing to increase in temperature. There's my crack. There's my gun. As you can see, the cell is starting to heat up. And just like as the camera indicates, you can tell by the different colors on the heat exchanger, the dark gray and the light gray, you see the different temperature patterns. It's kind of interesting to see where that crack happened, right on that dimple. And on this cell, or this heat exchanger, was both right and left cells that were cracked, and probably from a poor transition into a smaller coil. Just showing you, in fact, with my power in my hand, that the inducer is running. Forgot to mention that. So I wired up a plug inside the inducer going here. I'm trying to get the smoke thing going here and see if the will indeed pull through, and it's just not. I'll let it cool down for a second, and I want to test another theory. Maybe the hole's not big enough, so I'm going to drill a hole. And I want to take a closer look at this crack. So I'm going to sand it down, which seems to kind of close it back up. And then I really want to force this this crack to kind of open up. So I'm going to get the torch right out here and kind of see what happens. Again, this is an experiment. I just want to try to understand what's really going on. So heat exchanger experts, if you're out there, what are your thoughts? So here I am, just going to blast it away. I'm going to make it cherry red, and it's going to open up this crack pretty significantly. So. If you're a service manager or a trainer and you're looking to demonstrate heat exchangers and cracks like this, I suggest doing this. You'd be shocked to see how many guys actually have never taken apart a heat exchanger. All right, pretty glowing ready. I'm going to plug the inducer back in here. A little smoke gun in here, and it still does not pull in. It's interesting then, when you actually put heat in the cell, you'll get more thermal current than you'll get from the negative pressure of the inducer. So that leads me to believe that all cracks, whether they're just a hairline or pretty significant, are dangerous. Because think about it, it's not sucking in. So if it's not sucking in, can it push carbon monoxide or products of combustion out? Again, the inducer fan's on. It's just not pulling in. So heat exchanger experts, am I on to something? What are your thoughts? Anyway, if you'd like to learn more, I recommend visiting heatexchangerexperts.com for more facts on cracks. Stay tuned.